Good day, I'm Rocky, and this presentation is a carry-on to how I create hand-hammered flatwire. I've had several questions about how long it takes, and since I'm needing some for another presentation, I thought that I would film non-stop from start to finish the process. My last one was interjected with comments and a lot of cuts, so it took longer than what it really should. So what I have here today is a 120 millimeter length of 24 gauge stainless steel 316L. And in the end it's going to be flattened out something like this. Now if you're wondering about the deck, that is an Apocalypse deck that I use for building and tuning, setting up my coils before I actually put them in the RDA or Addy that I'm going to use them from or use them in. So the reason I did it this way is to start with, I'm going to place this piece of wire in the Addy. Pulled it all the way up to the handle I installed on it. If I can keep from being bubble fingered. Give it a little turn. Stick it back in again. Tighten that down. And check the resistance, which you can see is 0.43. And the reason I do it this way is because I'm looking for specific resistance for that piece of wire before I ever start wrapping it up. And I do this for most of my coils. My target is going to be 0.30 ohms. But this length of wire will give me some head space, some playroom to work back and forth. Plus, I wanted you to see an end comparison with the very same piece of wire tighten that down. There we go. To be able to compare the resistance from this state being round to what it's going to be after it's been hammered flat. This is a 510 or a 521 mini tab coil master. It only reads out to 1/100ths of an ohm, so this one is just a little bit off. It's probably closer to 44 this full length. So we have to give or take about 1/100th of an ohm in the process, which is not a whole lot. I did glow this beforehand just by putting it in there and heating it up. And watching for it to change colors, you see here. And that's doing nothing more than annealing it before I actually start to hammer it out. Now, what I'll do is take this out, let it cool down a bit, straighten it a bit, move this stuff out of the way, and then start hammering it. Put this to the side. Grab my handy dandy wire straightener. Give her a couple of good pulls. And that's straight enough to get started. Again, I work in the middle of the steel, straight up and down. I don't vary the angle of the hammer much at all. I try to stay straight up and down in the middle where it's dead, instead of off to the side where it rings. This is where what I call a sweet spot. So let's get started. If you watched my last video on how I go about hand hammering flat wire, you already know that I use a layer of bases to work on. The first is a 25-pound anvil, a cheap anvil, covered by the non-slip shelf covering, a rock block, I think it's granite, and then the shelf covering goes over that, and then my steel. That steel came from Harbor Freight. You can also get them from Amazon.com. And as you see in this one, I forgot to put my cover over the rock, and my steel starts slipping on me. As we go through this, you'll see me stop for a second and flip it up in place. Now, whenever I start working on this wire, I start at the base down where that blue tape is at, and I work from one end to the other. I flip it over and start back at the beginning and work it again. Each pass on this particular length of wire takes about 30 seconds if I don't stop in the middle and examine my work. Now that I got the shelf covering in place, the steel won't be moving around on me so much. You'll also notice as I go through this process that the wire is going to be continually moving, not only back and forth underneath the hammer, but also from side to side. It will curve quite a bit in some passes, and as it gets thinner, that curve will become more acute with each pass. That's not a problem, because when you flip it over, you start hammering again, you're just stretching the metal on that side, on the inside of the curve on the metal, back straight again. You'll also see that I move in very small increments, half an inch at a time, and that allows me to have more control over the wire and also keep it pressed down onto the steel so it doesn't get so much rebound, and I get more of the force of the hammer doing the work for me. I don't actually strike the wire, let the hammer head fall. Sometimes I'll put a little bit of pressure to it if I see a spot that's turning on me or needs to be flatter. As you go through this, you'll see me roll the hammer back and look at the wire. And what I'm actually looking at is not only which way it's curving, but also how wide it is. And if it appears too narrow in one section, I'll go back over it again. But for the most part, I'll go from one end to the other flip it, and go back again. Also, whenever you hammer out this wire, it not only bends from side to side, but it'll curl up from the end. That's not a disadvantage, because when you flip it back over, that curve gives you a spring to push against and holds it against that steel so that the hammer works better. You'll also see me pull it up and bend it back and forth and rotate it back and forth. I'm looking at how thick it is, and by bending it back and forth I can see if there are any stiff spots in it, and also see if there's any kinks. If I happen to strike it too hard in one spot, it creates a dent, if you will. That has to be worked out, because later on, whenever you wrap a coil, that one small spot that's thinner than the rest may create a hot spot in the wire. And if you enjoy watching paint dry, this sort of just tickle your fancy. This whole process, when I did this one, took me 11 minutes, and that included stopping and looking and investigating and checking my work. I'll let this run and make some more comments farther down the line. Now, if you're wondering about the noise this makes, all of these layers help to dampen some of that hammer noise, metal to metal. And I've actually checked this with a decibel meter, and the average decibel level on this is about 75 decibels. Some strikes I hit 80, but for the most part it floats around 70 to 75 decibels, which is a irritating tapping noise if that's all you're hearing, but for the most part it's not very loud at all. Now that we're approaching towards the end of this, it won't be just a couple of minutes longer, I'll be finished. I'm checking it again to see how thin and thick it is. Pay attention to the shadow cast from the wire on the hammer. As I rotate it around, that shadow will just practically disappear. It gives you an idea just how thin this wire can be. On average, this 24 gauge that I'm working with will come out to be about 1.3, 1.5 millimeters wide and just under 0.2 millimeters in thickness. That's on an average. It usually runs 0.15 to 0.19, something like that. It's quite thin and quite flexible, and the bending of it again shows if there's any flaws in it. And one thing I have to remember to do is once I'm finished with this, I need to go back and anneal it again, because all this hammering is actually hardening the wire and making it more springy. This process is actually called chasing. I know some people, you may have heard of a chasing hammer. Well, that's what we're doing. We're chasing metal down the length and the width of this wire. And the springiness comes from work hardening. And if I were to take this wire right now and try to make a coil out of it, I'd be wasting my time if I don't anneal it. It has so much spring in it. You can get it to bend around and make a circle, but it's going to expand back out. If you bend it around a 2.5 millimeter bit, as soon as you let go of it, it's probably going to jump up to 3 or 3.5. So it does need to be annealed before you actually start forming a coil. Now I'm almost finished with this wire. I just have a couple of little spots to work out that I'm not happy with, and you'll notice that I'm not using near the force or letting the hammer fall as hard. I'm barely tapping it, and that's all that's really needed to straighten out these little imperfections. Okay, I'm happy with the way that wire turned out. Now I'll put it back into the test deck that I used, tighten it down, and double check the resistance on it. And you're going to see this thing is gained. I think I measured it out about 0.16 ohms. It went from 0.43 to 0.59. That's a 14% increase in resistance. Okay, we checked the resistance. Now we'll take a measurement. If you remember, I started out with a 120 millimeter length of wire. This hammering process is not only widened, but also lengthened it to almost 140 millimeters. In fact, a 19 millimeter gain. Again, a 14% increase in the length, 14% increase in the resistance. That means I can use less wire to get the same resistance and cover a much wider surface area than the original round wire that I started out with. That's all I have for this installment and presentation, and I surely do appreciate you watching and taking the time to watch, and maybe you learn something from it. I'll be doing more in the future. So please subscribe, hit that little bell button, and you'll be notified when another one pops up. So for the time being, be safe and have a vape day.